In this video, I will show you how to do interpolation, particularly decimal interpolation. It is a skill that's needed to read the caliper. And in this video, we're not reading it, we're just getting ready for it. And I'm going to use this dial from an instrument panel to help you explain the concept, because this one has huge numbers on it. And this works perfectly for decimal interpolation. First, just what does it mean? What does it mean, decimal interpolation? Oops. Interpolation means to find amounts between two known references. I'll just go refs. So to interpolate, it means to find an amount, a new amount, between two known references. And although this one mentions the word amount in it, to do a proper reading on either on your caliper or on this gauge here, we need to find two pieces of information. One of them is the actual amount, and the other piece of information is the unit of measurement for the amount. It is important that measurement is just ugly. It is important that the unit of measurement be found. It could be inches, it could be millimeters, it could be fractions of an inch, it could be PSI, it could be RPM, it could be a number of things. It's important that the amount has a unit of measurement with it to make sense of the amount. Let's get started with the unit of measurement on this one, and come on in closer and take a good look at this contraption here I made. For all measuring instruments, there is an amount on them and there is a unit of measurement on them. On this one, this is the unit of measurement. It says X 1000 R / min. Let me just copy that one. And it says X 1000 R / min. That's what it says. What does that mean? It is a unit of measurement that is measured in revolutions per minute, also known as RPM, revolutions per minute, and it measures the how many number of times an object rotates, and it has a factor with it. It says it has a factor of 1000 times. It says times 1000. That X means times. What it means is that everything, the numbers here, should be multiplied everything by 1000. So this is not 1, this is 1000. This is not 2, it's 2000. But they didn't want to put so many zeros printed on the dial here, so they just put the significant digits, and the zeros you can fill it in on your own, because multiplying by 1000 is fairly simple. You just write down the leading digit and you fill in 3 zeros after it. So this is 1000, 6000, 7000, 8000 on this dial plate here. So that covers the unit of measurement. Now the amount. How do we read an amount on this one? Let me just put it here so you can see it. Now, to read an amount, there's 3 steps to it. Where do I write it? Where you can see it? I'll write it here. Find, or actually count, the divisions. Count the divisions. Come on in, zoom in closer. Let's count the divisions. What the heck is count the divisions? The division in this sentence is not a number operation. It's not one number divided by another number. The divisions are this. How many smaller units are there between the major numbered amounts? So between 3 and 4, and now we know it's 3,000 and 4,000. How many little smaller marks are made? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 marks. So 9 marks, we'll divide the difference between 3,000 and 4,000 into 10. 9 cuts, that's going to give you 10 slices. So the divisions are this 10, number of divisions is 10. There, just wait for the camera to focus. Number of divisions is 10. And what you do next is I'll show you on this thing. Here is this ever handy office staple. Here is going to be the needle, and at this point it's pointing at this moment it's pointing at 0, so the reading is 0 RPM. Here it's pointing at 1000, it's pointing at 1, and the reading is 1 times 1000, so it's 1000 RPM. It's pointing at 2000 RPM. Okay, what is it pointing at now? It's pointing at exactly halfway between the 2 and 3, and you write it down as 2.5. Why 2.5? Because the numbered amounts have 10 divisions. We just counted 9 hairlines on it, but 9 hairlines divided into 10 equal parts, because we're not counting the hairlines, we're counting the gaps. Okay, so 9 hairlines will give you 10 equal little spaces between 2 and 3. So this needle is pointing at exactly between 2 and 3. It's a 2.5. And then you have to multiply it by 1000, and then you write down the result. It's 2500. That's how this works. This interpolation works. Interpolation doesn't quite mean guesswork. Okay, how about that? What is the needle point now, or the office staple is pointing at? First step, you count you go from 0, you count the major amounts, and you write down that 2 is the major amount, and then you count the smaller amounts, and you go 1, 2, 3, 4, 5. The 5th one is a biggie, so 5 plus 1, that's 6 of the smaller ones. That's a 2.6. Between 2 and 3, that number is 2.6, and you times it by 1000 to give you 2600 RPM. That's the last thing that you write down, the unit of measurement there, 2600 RPM. Now I want to get in even closer. What number can be found exactly between 2.5 and 2.6? It's finicky. Thereabouts. What number is the office staple pointing at now? It is pointing at a number exactly halfway between 2.5 and 2.6. So say if this was a number line here, and here is 2, and here is 3, it's pointing at this particular position there. So if this one is 0.1, that's a 0.1. This is 2.1, 2.2, 2.3, 2.4. This one is 2.5. That one is 2.6. It is between 2.5 and the 2.6. And here the number is 0.55. There. This number here is 0.55. There. So the answer is that at that point it's 2.55 times 1000 equals 2550 RPM. There, 2550 RPM. There. Now lastly, that new arrow that I drew, to what number is it pointing at? If it's halfway, exactly halfway between the 2.55 and the 2.6. It's, let me just, where do I write it? Here. It's 2.55 and 2.6. What number is exactly between 2.55 and 2.6? Well, the difference between 2.55 and this is how it can be found, probably the easiest. 2.6 is the same as 2.60, and you can subtract from 2.60 2.55 and you come up with an answer of 0.05. When you subtract, where do I write it? I'm going to write it here. 2.6 minus 2.55, this is 2.60, the answer is 0.05. So now we need to have that amount, because that's the difference between them. Now we need a half of it, and we need to increase the 2.55 by the half of the difference. 0.05 divided by 2 is 0.025, 25 thousandths. Let me just zoom out so you can have a better scale. There we go. So now this 0.025 has to be either added to the 2.55 or subtracted from the 2.60. I guess it's easier if we just add it to the 2.55. And you have to keep in mind that the 2.55 is a 2.550000. If you need to fill it in with decimal zeros, just feel free to do so. And when you add it, 0 plus 5 is 5, 5 plus 2 is 7, 5 plus 0 is 5. That's a decimal dot. That's 2. The answer is 2.575. And when you multiply it by 1,000, you'll get 2,575 RPM for this exercise here, 2,575. And this particular skill at the bottom of the page here is particularly important for finding decimal tenths and decimal hundredths for measuring successfully in metric or in imperial, mostly in metric, on the caliper. And then finally on this plate, the final amount is so small I can't even accurately place this needle for it because it's just too thick for it. But you can see it on the number line there on the bottom, where 1/10 is a greater division than it is on the dial plate. So that's how to interpolate. It takes some handiwork, and you need it for reading the caliper.